Hello. Today we will present the new features of our Brida tool. We will present the new features of versions 0.4 and 0.5 because we should present version 0.4 in Hacking Paris 2020, but the conference has been postponed to 2021 to the global COVID pandemic situation, and consequently we released the version 0.4 last year, and we will release version 0.5 in the next days. But we will present the new features of both the versions today. I am Federico Dotta. I am a principal security analyst at Agent Security, a security company focused on offensive security that belongs to the Human Activa group. I will present this tool with my colleague and co-author of Brida, Piergiovanni Cipolloni, that is also a principal security analyst at Agent Security. What is Brida? Brida is a Burp Suite plugin that acts as a bridge between Burp Suite and Frida. I think that everybody who worked in web application security testing know Burp Suite. That is the de facto standard for this kind of assessment. It's a suite of tools that include an HTTP proxy, a powerful fuzzer named Intruder, and a great automatic scanner. Furthermore, it exports APIs that allows to easily extend all its functionalities, and for this reason is a very good tool for penetration tester. Frida is a dynamic instrumentation toolkit that allows to debug live processes and that is scriptable. So it's possible to execute our own debug scripts inside another processes on multiple platforms, among with Windows, Mac, Linux, iOS, and Android. Frida is open source and is becoming the de facto standard for this analysis too. Brida acts as a bridge between these two tools and allows to call mobile application functions directly from Burp Suite using Frida. Thanks to Brida, it's possible to create very simple Burp Suite plugins that call mobile applications inner function in order to execute complex tasks without to have to re-implement them. For example, encryption tasks executed by the mobile application are directly called inside the Burp Suite plugin using Frida instead on having to understand how they work and having to re-implement them in a dedicated plugin. How does Brida work? Brida is made up of a main plugin that creates the bridge and that offer a lot of different tools. This plugin creates a Python server based on Pyro 4, that is an RPC library, that allows to talk directly with the Frida server that run on the mobile device. Then with Brida we can create many different custom plugins that use the same bridge to talk with the mobile device. Thanks to the RPC object of Frida, it is possible to expose RPC-style functions that, using Pyro as a bridge, we can call directly from our Burp Suite plugin, and we can collect the returns of this computation executed on the mobile device. First version of Brida was simpler than the current version. Create this bridge and offer basic instrument to use it in order to create external plugin and to move this complex task on the mobile device. Then, with version 0.2 and 0.3, we added a lot of different tools. For example, an integrated JavaScript editor, an integrated Frida console that collected the output of all Frida and Brida hooks, and a dedicated tab that create a tree representation of all the mobile application classes and methods, and that allows to graphically create inspection hooks that print arguments and return value of the chosen functions, and replacement hooks in order to change the return value. Now, with the newer 0.4 and 0.5 version, we improved the functionality of Brida much more. Now we have a highly customizable engine that allows us to graphically create a Bullshit plugin without the need of coding. Besides that, we create a new dedicated tab that collect many different Frida hooks that are very useful during our everyday operation in order to bypass common security features or inspect common security code. It's easier to use thanks to the integration of Frida Compile and Python virtual environments, and now we have also a documentation. Uh, this is the hooks and function tab that collect many different Frida hooks developed by different tester and security researcher. And these hooks can be used to bypass pinning, to bypass fingerprint protection, routine check, to inspect crypto stuff, keystore stuff, and so on. And in the last version, we added also a functionality to demangle Swift names, both in the hooks and function tab and also in the graphic analysis tab. The graphic analysis tab was already present in version 0.3 and allow us to analyze classes and functions of target mobile application and to add inspection um, and inspection hooks that were not persistent across different run. Now we added a new tab named graphical hooks, and these hooks are persistent and can be enabled, disabled, or removed in the tab. This is an example on how we can add an inspection hook, for example. And now all these hooks, inspection or edit hooks, can be enabled, disabled, or removed in order to make these hooks persistent across different runs. But Brida was born to handle complex situations. For example, an application that encrypts the body of all requests and responses with a custom and heavily obfuscated algorithm, or an application that signs the body of all requests. In all these situations, we need some tool to help us and speed up our analysis. Because without Brida, in order to be able to test the backend API of the application, we need to reverse this application in order to understand how this encryption or other security mechanism works. And we need to code these encryption signing features in our dedicated plugin. So it requires a lot of reversing and a lot of coding. With Brida, till version 0.3, all these works are greatly speed up because the reversing job is aimed only at finding encryption or signing function without the need to understand how they works. Because once we find those features, we can code very simple Bullshit plugin that call these features without the need to re-implement them. And so we add an exported function to Frida JavaScript file that calls the mobile functions we need, and we collect the result back in our Bullshit plugin. Now we improve this mechanism much more with version 0.5 because we don't need even to code a simple plugin. But now we have a new tab in Brida plugin that allow us to create custom plugin directly from Brida GUI without the need to even write a single line of code. We can write 4 different types of plugin: HTTP listener, message editor tab, context menu, and JButton directly from Brida GUI. This kind of plugins I think that are known to anyone who already coded a Bullshit plugin, but we will show them and explain them during the demo. We have many different configurable ways to pass parameters to Frida and to collect back the output. We support many different encodings, and we have debugging and import-export functionalities. This is an example of this custom plugin tab. In the upper part, we can configure our plugin, and in the lower part, we have all our plugins, and we can enable usable then, edit and remove then, and we have a detachable debugging window that is very useful to understand if our plugin is working correctly. And now it's time for the demo. We will look at two different demos. The first one on an Android application executed by my colleague Piergiovanni, in which he will show you a quick walkthrough of all Brida features, and we will show you the creation of a iContext menu Brida custom plugin and of a iMessage editor tab Brida custom plugin. Then I will show you a different demo on an iOS application in which we will see how to create an HTTP listener Brida custom plugin and how all these plugins can interact with Brida with Burp Suite tools. Thank you, and let's look at the demos.
Right, in this demo we will walk you through various Brida features with real-life examples. In fact, this is a very common scenario for mobile penetration testers, in which you have an app running on your device or your emulator, and your device is configured to proxy all the traffic through Burp Suite proxy, because you want to inspect or tamper the message exchanged by the app and between the app and the backend server. This app is a very simple app. It just sends and receives data. And without further ado, let's see what happens when we click on send and receive. Whoop, we have an error, and we have a dashboard tab blinking. And it's blinking because indeed we have an error. The client failed to negotiate a TLS connection to its server. So we have most probably an SSL pinning issue. So let's get straight into Brida. In the hooks and function tabs, Brida provides various helpers for iOS or Android devices. These are basically Frida scripts embedded within Brida, and these can be very useful. For example, we have two different SSL pinning bypass scripts. So let's have a look. The first one, let's try the first one. But before we do this, we have to go back to the configuration pane, write down the process ID of the app running on our emulator, which is 2146. We can also use the application ID, the package name. In this case, we want to attach this running application. So first thing is start the server. The server is running. Now we go back to hooks and function. We click on enable. So we enable this embedded Frida script. And we not touch the application. Now let's see what happens. This might take a while the first time we attach. Right. Our app was correctly attached. We can see the output of the SSL pinning script, which is initialized. So let's have a look and try again to click on send and receive. Whoop, we have our data back. And in fact, our script intercepted the SSL pinning routines, which in this case are performed by the OK HTTP v3 library. And if we go back to the proxy, we don't have the error, and we finally see the traffic flowing, the request and the response. This looks like base 64 encoded string. So let's select and try to convert the selection. Whoop, this looks like binary data. Let's have a look at the response. We go to the decoder, and we decode as base 64. Yep, this is binary too. So that means that most probably this application is using crypto routines to exchange data with its server over TLS. We go back to Brida, we detach the application, and we go to the hooks and function tab. And let's have a look. We have hooks for crypto stuff. Cool. Since today we feel lucky, let's enable this too. Let's clear the console, attach the application again, and let's see what happens. Whoop! We're lucky indeed. Our crypto hooks hooked the doFinal method, which is used by the app to encrypt and decrypt, encrypt the request and decrypt the responses. In fact, this looks like exactly what we've seen here. And this one too. Yep, same thing. Cool. So without even decompiling the application, we just found that the application uses the doFinal method, which is very common for encryption and decryption functionalities in Android application. And these hooks give us the input buffer, which, whoop, that's what the application sends to the server. And this is the response, which gets decrypted. Let's see what's inside. Yes, here's your data, the message we had on the display here. Cool. Basically, we now know the application uses encryption, in this case AES CBC, which is also deprecated. So we know now that the application uses the doFinal method from the crypto class. So we don't need these crypto hooks. So we just click on this. We attach again the application, clear the console again, and we move into the graphical analysis tab. And we just click on load tree. The tree is successfully loaded. As you can see, we have two trees. This one for the Java classes used by the application, and this other for the native libraries. What we can do now at this point is go here and search the doFinal method, and let's see. Whoop! We have different classes. We're interested in this one, the JavaX crypto cipher. As we can see, we have different overloads. These are all the overloads. What I'd like to know now is which method invokes the doFinal. So one thing we can do is we go back here. We just click on randomly and start typing JavaX. There we go, Java crypto cipher. Double click on this, and we have all the methods of this class. And we have, as you can see, we have the doFinal methods and all the overloads. If we right click on this, we have three options. Now we are interested in inspecting with backtrace, because we want to know who is invoking the doFinal method. What's the original method or original class invoking the doFinal? So we do this for every instance or every overload, because we don't know which one is used yet. We clear the console, and we click again. There we go. So basically we use do final with just one input, one argument as an input. And this is the stack trace, the back trace. This is the native method, the do final, which is in fact called, invoked by an encrypt method from MioCrypto class. And this is cool. So we close this. We go over here, graphical hooks. We can find all the hooks we previously selected, enabled. At this point, we don't need them anymore. We can click on disable. Well, we have to detach first from the application. And we go back to the graphical analysis. We now know, as I said before, we now know this is the class and these are the methods. So let's have a look. Click on this and just start typing com.dom. There we are. Here's the class we're interested in. Double click. Yes, we have to attach the application again. Double click. Oh, we are very lucky today. We have just two methods which take a string in input as input and return a string. Very, very cool. So basically we need these two methods to encrypt and decrypt the data we see flowing through the proxy. One thing I'd really like to do now is I really would like to have the ability to select, right-click, and decrypt. So we need to, in order to do this, we need to write a burp plugin, which performs all this operation. And that's when Brida comes in handy. So if we go to Brida, we introduced the custom plugin tab, which let us write burp plugins basically without writing almost any code. So we have 4 different kind of plugins. In this case, we're interested in iMessage. Well, no, we're interested in iContext menu because we want a specific right-click menu like this one. So let's call it my decrypt. iContext menu is a plugin that adds a context menu option to Burp Suite right button menu. We need to tell Brida which function Frida is exporting. Now we call it, for now we call it my decrypt. Remember, this must be lowercase. We'll see it in a bit. Why? That's the name of the button from the right-click menu, my decrypt. What we want to manipulate, we want to manipulate the highlighted value in requests and responses. We don't need no encoding, since we've seen that the method, the encryption and decryption methods accept plain string. And what we want the output, the plugin output, to replace the highlighted value. No encoding. And just, we have a plugin. Yes, we have a new plugin. At this point, so if we go back to the proxy pane and we select this, we need to enable that before we go back to proxy. We right click on this extension, Brida, my decrypt. Cool. But now we still have to tell Brida and Frida what to do. So we go to the JS error editor. We load the default Brida JavaScript file. That's it. As you can see, put here the exported function called by your custom plugins. Super cool. We have a special section for this purpose. So we just need to do this. MyDecrypt is a function that gets a message as an input. Wallet use. We need this class. And this is for the decryption. Let's do a similar thing for the encryption. We call it myEncrypt. That's it. Save. Detach the application. Let's compile it again and attach the application again. Whoa, cool. Now we go back to the custom plugin and we write another one for the encryption. This is the exported Frida function. We just wrote this one, which basically tells Frida to use the encrypt method from this class on the message. So let's finish myEncrypt. Let's add this, enable this. We can also open the debug window. Keep it aside. Now we go back here. We select this. We go to extension, Brida. Yes, we have two buttons. Now we need the myDecrypt. Yes, it's working. Basically, let's have a look at the debug window. That's where we pass this to Frida. Frida performs the operation using the app very own code, and that's where we get back. So we can do this on the responses as well. MyDecrypt. Here's your data. Cool. It's working flawlessly. Now, next step. We can either send this to repeater and do something like this. Whoop. Encrypt it again. Whoop. And let's see if it's working. Yes, it is. Here's your data. Super cool. This lets us tamper this message, because if we go to, we decrypt it and try to re-encrypt again and see what happens. Whoop, we have a response. Yes, your secrets. Now let's see another plugin example. We go back to Brida tab. We disable the one we just created, and we move on to the iMessage editor tab. Let's call it my crypt. Okay, this one is correct. We want to execute it on the all requests and responses. We execute it always. We want to apply it on the body of the request to the responses. We don't need no encoding. Let's call it my crypt. And now we use the my encrypt Frida exported function to re-encrypt what we modify. We replace the request response body and just add it. Remember, we previously wrote the my decrypt and my encrypt function, Frida export function. Let's go back to custom plugins. Let's enable it. And let's move to the repeater. Now we have this. So we click on this. Now we can do this and just send it. Here's your secret. And send it. Is your data. So the my encrypt and my decrypt function are working behind the scene. No need to decrypt or re-encrypt or re-encode. Just do it on the fly.
Hello. After Piergiovanni's demo on an Android application, we will see a similar demo, quick demo, on an iOS application. The application is shown on the left, and it presents a simple form that allow us to search for things. For example, if we search for meat, we can see in the lower part of the screen that we have the price of the meat. If we try to inspect the HTTP traffic, we can see that beside the name of the endpoint that is encrypted, also the content of the request and the response are base64 encoded data. And if we try to decode this base64 encoded data, we can see some sort of binary data, probably encrypted or obfuscated in some way. So in order to be able to execute some test on the backend API, we need to find a way to overcome this encryption problem. And we can use Brida. We will not execute all the steps because Piergiovanni already did. The encryption and decryption methods are contained in a class named encryption. We can look at them in the graphical analysis tab after loading the tree. Inside the Objective-C section, we find encryption, and with a double click we can see the methods of this class that are decrypt response and encrypt request. We can add an inspection hook to these methods in order to verify if these methods are correct. One thing, we add also a demangle Swift name option to the Objective-C pane that can be used to demangle Swift mangled name. This feature has been added both in graphical analysis and also in a button in the hooks and functions tab. So now we have added inspection hooks. We can try to search again for meat. And as you can see, we have some prints. The encrypt request has been called, supplying as argument the term meat. And the output of the encrypt request function is this one. As we can see in the proxy, it is exactly the word sent in the request. As the same, the decrypt response is called, supplying this argument this value, this base64 encoded value, and it returns a clear test value, meet price 3, that we can see in the application. If we look at the RWO, it is the same as we can see in the response. So now that we have the correct functions that handle in the mobile phone the decryption and encryption, the first thing that we have to do is to build a couple of Frida exported functions that we can call in our plugin in order to handle encryption and decryption. So we go to the JS editor, we click on load.js file, we open brida.js file, and now we add here our two exported functions. So the first one, named encrypt, that handle encryption. If c.available, var encryption class, we take a reference of the encryption class named encryption, as we saw before, and then we return the output of the encrypt request function. We have to use the underscore instead of the colon because it is the way in which the colon is handled in Frida. I forgot the parameter, that is one single parameter that I will name message. And so we can pass this message to this function in order to be encrypted. Dot to string. This way, this exported function named encrypt will take the argument we supply to this function, and it encrypt this argument with the encrypt request function of the encryption class. Now we can copy this method and we can paste it in order to create the decrypt that is similar. But we'll call the decrypt response function. Now we can save JS file and we can click on compile and reload the JS. This is a warning caused by dependencies of Frida compile, but it's not a blocking issue, it's a warning. Now we can try our exported function in order to see if they work as we expected. So we go to the debug export tab. Now, first we can call the encrypt, passing as argument the word meet, for example, and we click on run export. As you can see, the encryption has been executed, and we try if the decryption function works in the same way. So we copy the output of the encrypt, and we call the decrypt. And the output is meet. So our exported functions works well. Now we can build our plugin directly from Brida graphical interface. Piergiovanni showed us a way to handle encryption. Two ways. One with the context menu option, and the second one adding a specific tab. Now we will take another approach. We want to be able to insert here clear test value that are encrypted transparently by Brida. In the same way, we want to see here a decrypted value that is decrypted by Brida transparently before showing us. So let's send this request to the repeater. So first things, we want to create a plugin of type HTTP listener that handle transparent encryption in order to be able, for example, to write meet here and to have transparently this word encrypted by our plugin. This way we can use repeater but also intruder or scanner, because if the encryption is handled transparently, all the Burp Suite tools can be used. So let's go to Brida. We create a plugin named HTTP Listener named Transparent Encryption. Type HTTP Listener. The name of the Frida exporter function is encrypt. Execute on request of the tools repeater, scanner, and intruder, but we can choose every tool we want. Then we can choose when our plugin should be executed. In this example, we can say him to execute our plugin when we have, for example, this text in the request. So when the request response contain plain text content equal. Then we can pass parameter to our Frida exported function. We have one parameter that is the content of the content parameter. We can use a regex to pass this parameter. So content to, equal and a regex that pass the parameter with the parentheses with the regex group. We can also encode the function parameters or Frida return value, but in this situation we don't need to do so because input and output is in UTF-8. But if you are using, if you are working with binary data, it's better to use encoding, because sending back and forth binary data through pyros sometimes have strange behaviors. So if you have binary data, for example, encode in base64 and decode the value in the Frida exporter function. The plugin output, so the value returned back by Frida, we want that this value replace the original one. So again, we use a regex and we put the return value of Frida in the content parameter using a regex. Now we can add our plugin and enable our plugin. Now, if we go to the repeater and if we click Go, as we can see, the value has been accepted by the backend, but at the moment we don't know what is the content of the response, because we have to take care also of the decryption phase. So let's add another plugin of the same type named Transparent Decryption. Same type, but that's called decrypt exported function. Execute on responses of the same tools. But now we have all the body that contain the encrypted value. So we execute always, because we don't have a specific parameter, and the parameter supplied to Frida is the entire body. In the same way, we want to replace with the output of Frida the entire body. Now we can add the plugin, enable it, and we can try again to use our function. As you can see, now we have an encrypted value and unencrypted value in the request and in the response. And we can test this application as a usual one without handling the encryption that is handled transparently by Brida. We have many advantages of this approach because, for example, we can use the scanner. For example, maybe we want to search for SQL injection. We can send this request to the intruder in order to be able to select a parameter, and we can scan the define insertion points. I create a profile only for SQL injection in order to, for speed purposes. And we scan this parameter. It is better to use maybe one thread because every request and response is handled by Frida back and forth to the mobile phone. And the burp can remain quite stuck until the scan or intruder finished. But as we can see, it found a SQL injection because it inserted a single quote and it obtained an SQL error. With two single quotes, no error is displayed. So, in the same way, we can work also from the repeater. SQL error, meet, for example, and we have all the results. And that's all. The last type of Brida custom plugin is named JButton, and simply add the button to the hooks and function tabs, Android, iOS, or other. It can add two types of buttons, one that enable or disable an hook, and one that execute a function waiting for a return value. It is useful when we have some Frida functions that we want to call directly from the GUI that maybe we use a lot of times. One last thing, we saw how to build a plugin from the graphical GUI, but it is still possible to create our custom plugin in Java or in Python and use Brida Bridge to move part of the computation to the mobile phone. As in previous version, in the generate stubs pane, we can generate Java stub or Python stub that we can copy and paste in our plugin to take advantage of Brida features. And for this talk, that's all. Thank you. I hope you enjoy this presentation.